This is Masonry Problems Part 1. Until now, we were doing a review of Structures 1, and it was quite challenging to do all this review in 2 weeks. Unfortunately, you were supposed to know this material before starting this class, and I could not spend more of 2 weeks doing this review. But the good news is that now we will be starting with the material of this class, with the new material. We will be starting with Masonry. That is a very good and incredible material, and we will be doing some problems. And obviously, because this material is new, we will not be running like before, and you will have enough time to learn and understand the problems that are not complicated at all, are very simple. There are several types of Masonry problems: wall stress calculation, wall thickness calculation, shear and wall spacing and thickness, and other more. In this model, we'll be doing only wall stress calculations. And the wall stress calculations have 3 parts: weight of the wall, actual stress, and the stress that is allowed. All these 3 parts will be evaluated. But remember, these problems are simple, and you will just need to use and apply some formulas and tables. It's not necessary to memorize the formulas. Of course, neither the tables, not only because this particular material for the test 3B of problems is open book, but also because you find this information in the internet, and in any book, it's no matter to memorize something that you will forget the next day or the next week. In these particular problems, we'll be working with empirical methods. What is empirical methods? Empirical methods are the ones that are not scientific. They are made after working with experience. And before looking at these problems, you need to read the chapter 41 of the textbook. All the problems you need to resolve will be always in the slides. They are very similar or the same of problems that you have in the books, but you will look at the slides because in the book you have additional problems that will not be part of the material of this class. However, in this particular test, the theory that is necessary to understand these problems is in the textbook. In the textbook, it's explained that the calculations methods here presented are not scientific, but empirical. What means that? That they are based on experience and what is called in French the savoir-faire. After the people start doing something, with the time they learn what is the best method. It's not based in mathematical exact calculations. These methods can be uneconomical sometimes, but are very practical. They are permitted only in some type of buildings. In order to do the first part of those problems for module 1, we need to understand what is the table of this compressive stress that is allowed in walls. This table is divided in 3 different columns. The first column is the one that tells us the base, the stress that the units can support. That is the base of the table. And we have units that have a specific PSI that are supporting, and is also here next door, you will see that there is in megapascals. We will not be working in megapascals. Well, we will use from this table only the areas that I have here in blue. This one here, or this. Also the one that is here going down until the end in PSI, and also this part here with the units are in PSI. Well, here in red is the base. The things that you need to be looking. And it's the PSI that is one of the material is supporting. And after, in blue, you will have the PSI according to something very important, that is the type of mortar, if it is S or if it is N. For each one of them, you will have several materials. The materials will be in green color here. This is a material type of wall. When I speak about material, I say it's all masonry, but what type of masonry? And well, we have hollow units, hollow walls, grouted stone masonry, solid masonry, etc. We are not working with stone ashlar in this particular case. Okay, our table will finish here where is this line. And thereafter, for each one of those materials that are in green, we will have in yellow color a particular PSI. Well, in few words, the solid masonry wall, for example, is this type. And in this solid masonry, we have two possibilities: M mortar or N mortar. MOS, that is the same for values, or N mortar. Let me go back and show this again. Finally, between all the type of solid masonry, we will choose which one we want. And that depends on the PSI. Please be careful. If you need a wall of 3000 PSI, which number you will use if it's a solid masonry brick wall, the one in the top? You will not use 2500. It need to be more than 2500. The same or more. Well, you will use 4500. If for the contrary, I tell this problem has a particularly wall, for example, again, the one in the top, solid masonry of brick, clay, or concrete, you will choose 2500 if that is the PSI that is support. You don't need to go up. Well, it's equal to 2500 or less, equal to 1500 or less. Okay? Let's clear everything and continues. In the textbook also, you will find a series of tables that we will not be using in this particular module. That is for the next one. And you will have some formulas. The formulas are very simple, are related with wall thickness. The thickness of a wall, obviously, is how thick the material is, and the length of 1 feet. That will be the number that we will use for half the surface of this wall. The weight of the wall is the same as stress. Stress is weight divided by area, force divided by area, load divided by area. And in our case will be P divided by A. And some other things that are very simple and we will be showing here. Well, now I will show you 3 problems from 1A to 1C related to wall stress calculation. These 3 problems have 3 different parts, and I will be doing these parts 3 times. It's not complicated at all, and I expect all of you to get 10 in this test because it's not difficult, it's simple. Well, problem 1A, we have the data of this particular wall. It's a wall that is 10 feet high, has a material that is hollow load-bearing walls of 1500 PSI with a mortar that is S. I mean, every unit is able to support 1500 PSI. The units together with a mortar that in this case is S-type. A type of mortars is something that you need to study in your theoretical part. Nominal thickness, the thickness of this wall is 10. It's called nominal because that is the one that gives the name and the one that we use when we will buy these blocks. I want a CMU of 10 inches. But when you measure, it's smaller. It's like they are cheating on us. They are making the material smaller. The real thickness is only 9.625. Those are for conventions. And it's also because it will help to don't overcalculate the thickness of the material that we cannot put the walls because for some mistake it's a little bit smaller. The total load that the wall support is two things, the dead and the life. You will receive both of them together. There is no security factor, it's just 5,000 pounds in this case. And the weight of this wall is 10 inches. The weight of this wall that is 10 inches thick is 100 pounds per square foot. I mean, we don't care how long this wall is. In no place is written how long is. Everything that we need to calculate is related with what happens with 1 linear foot of this particular wall. We need to calculate 3 things, as I explained you: weight of the wall, actual stress of the wall, and the stress that is allowed. I will explain that now. Let's go with the first one, weight of the load. This is so simple. This load has a height of 10. It's written 10, okay? And the weight of a wall of this type with this thickness is 100 psi per every feet, obviously. Well, you can look here, the small arrow is only 1 foot long. It's no matter how long is the wall, as I explained you. We calculate what happens in 1 feet. Well, we multiply 10 by the weight that 1 feet of this element has. It's like this weight, 100 psi, is the weight of 1 square foot of this particular wall. We multiply by 10 because we have 10 square foot. We can divide this 1, 2, 3, 4, 5 because the height is 10. Well, the total will be 100 multiplied by 10, 1,000. It's very simple. Step number 2, we need to calculate the actual stress. Actual stress is force mean. As I explained you, the formula of stress is weight, load, or force divided by area. In this case, we have a force mean that is the total load, that is 5,000. We divide by 12 and we got 43.29. Why we multiply by 12 inches? Because remember, we're calculating a stress. Let me go back. We are calculating a stress. Well, we have the total load that is 5,000, but the area is not the thickness, it's the thickness for every feet long. Well, we need to multiply 9 by 12. That will be the area of 1 linear foot of that particular wall, and is supporting 5,000. Well, we need to divide 5,000 by that particular element. That means that every PSI, every pounds square inch will be support, every square inch will be supporting 43.29 pounds. We are done with step 2. Step 3 is very simple. We know that our wall was a hollow low bearing wall. We also know for our data that the mortar that we were using was this MOS mortar because it's the same, it's no N. Well, we just go to our column of mortars and make here like a long square, and we know that this is the data that we need. We don't need N mortar, we only need M or S. After, from all the type of wall, we will choose hollow load bearing units, and we will choose the specific row of 1,500 because that wasn't the problem, where the two elements cross is 115 psi. Well, we have the 3 answers to our problem. In the test, you will have to answer and write a number in 3 blank spaces. Well, in the first blank space, you will write the first calculation that you did. In the second that is 43.29, and in the third, the result of the table that is 115. What we were doing first, we calculate the weight of the load, as I explained before, and it's something that is not difficult at all. We calculate 100, that is the weight of 1 feet by 1 feet of this material, and we multiply by 10. Well, we calculate this area here, this length. That is the weight of that particular load. After we have some data that tell us that this wall have 1,500 PSI and it has a total load of 5,000 pounds, have a linear foot of 9.625, that is the real one, and the nominal is 10. For the first problem, we use 10. For the next one, we just divide 5,000 by the total 1 feet, that is 9.25 multiplied by 12. And finally, we just locate the compressive stress and we write the 3 numbers. That is all that you need for module number 3. I will do this problem again twice. Problem 1b is similar. We have a wall that again is 10 feet tall. The material is different, it's clay grout, masonry of 1,000 PSI. The mortar is N, is also different. The nominal thickness is 8. 8 means 7.62 in the real dimension, and the total load is 6,000. Because this material is not as thick as before, also the weight of this particular wall is 800 pounds per square feet. We need to calculate the same. Let's start by weight of the wall, and we multiply 10 by 80, and it's 800. That is pounds per linear foot. We don't care how long is the wall, it's not relevant, but 1 feet have a weight of 800 pounds per linear foot. Every linear foot will be 10. If the wall is 20 feet long, it will be 20 multiplied by 800. Next, actual stress. Easy. We divide the total load that was 6,000. Let me go back, sorry. That is 6,000. We divide by 1 feet of the area of that wall. And then we need to use the real dimension. We don't use 8, we use 7.625 because we need something exact here. And we need to multiply by 12 because everything is referred to 1 feet of the wall. Well, we have the area, 12 long, 7.625 inches of thickness. That is one area of 1 feet. We divide 6,000 by that number, and we got 65.57. We got the second answer. Tier 1. Well, according with the mortar, it was N, as you remember. According with the wall, is grout masonry, and it was 1,000 PSI. This is the row that we need, and this is the column. Answer 100 PSI. What happened here? We have a wall of a weight of 800 per linear square per linear feet. That particular one have this particular stress of 60.57, but by law is allowed to have 1,000. What that means, our wall is okay. The stress that is supporting that particular wall is 65.57, but according with the table, that wall is able to support 100 PSI. We are safe. And those are the 3 answers that we need to write. Problem 1C. Here, we have a wall that is 12 feet high. It's made of masonry units. This particular material is supposed to resist 2,500 PSI. The mortar is N. We have a particular thickness that is 8. Again, we have a particular total load that is 3,000 pounds. The weight of this particular wall is the same as the problem before. It will be 80 pounds per square feet. The nominal thickness is the same, is 7.625. We need to do the same calculation, weight of the wall, actual stress, and the allowed stress. Well, what we do, again, we multiply the height of the wall that is 12 by 80, 960. Ready. Second, We calculate the actual stress, that is the force 3000 divided by 12 multiplied by 7.65. Finish. Very simple. Stress is force divided by area. And the force is the weight that load is supported, that is 3000. And the area is always 1 foot multiplied by the thickness. In this case, the real thickness is not 8, it's 7.625. And this is ready. And finally, this particular wall, it was a solid masonry brick wall with an M mortar, 2000 psi. We put all those lines in the table and we arrived to 140. Well, the wall is supporting 32.79 critical stress, but that wall is able to support 140. Our wall is okay, no problem. For the next model, we will do several types of problems, and the first one will be wall thickness. But for this particular model, we are ready, all the material is complete.